All right, welcome everyone. Great to have you again on our webinar. Today we will speak about world-class manufacturing and Kaizen in a post-pandemic manufacturing world. Our guest speaker is Professor Norman Horwitz. I am Jabril Bensedrin, hosting the webinar on behalf of CESA Systems. Just a few words about Norman. He is a Professor Emeritus at Tulane University, the School of Engineering and Science. He comes not only with an academic background, but also industrial engineering experience at Volvo, General Motors, Westinghouse. He's been a consultant for a number of years with some kind of the companies you see here on the screen, Johnson Controls, and so on, different sectors. He also has additional credentials, Tulane University Medical Center, Quality Improvement Committee, and so on and so forth. It would take me the entire webinar to tell you everything that Norman has achieved in his career. He holds a Bachelor of Science in Mechanical Engineering and a graduate degree in Industrial Management. He started also at the US Navy. So thank you so much, Norman, for being with us. The topics that Norman will discuss include really going back to the basics and how that can help achieve the challenges, or let's say undertake the challenges that many companies are facing today. Some of the topics he will discuss you see listed here. However, there will be time for Q&A. Also, feel free to ask questions anytime. If there is any question, clarification question, or something you would like Norman to elaborate on, please feel free to send the question in the chat. Actually, there is a section you should see on your screen on your dashboard for questions. So just a very few words about our host and sponsor, CESA Systems. Many of you are already customer of ours. We provide a complete catalog of products for equipment and accessories for lean manufacturing, continuous improvement, operational excellence to a number of companies, including some very large and thousands of smaller companies. What you see on the screen in white are the production equipment, colored, coded are the equipment we provide, training games, ergonomic lean office furniture, ergonomic workstations, in the logistics, floor racks, trolleys, Kanban systems, floor marking, safety signage, transparent shields, Industry 4.0, wireless and-on lights, digital screens, digital KPI management software, visual management, magnetic whiteboards, and accessories. Without further ado, I will pass it on to you, Norman. Thank you again for being with us.
Thank you. Welcome. It's afternoon for everybody, I guess. And what we'll start talking about is, even though we have some problems lately, I think the skills that exist in manufacturing will be enough to solve the problems and new challenges that we're going to experience. But I think we have the skills. I just think we need to rearrange them, take a look at them from a different perspective, and just go ahead and do what we're good at doing. The first thing I like to do is first define Kaizen. The Kaizen approach is to create continuous improvement based on the idea that small, ongoing, practical changes can reap significant benefits. So that's a kind of a very focused approach. It has worked quite well. The 5 elements of that are teamwork, personal discipline, improved morale, quality circles, and suggestions. Again, this is just a basic approach. When you look at world-class manufacturing / world-class service, that is a much broader approach to improvement. The definition of world-class manufacturing is a manufacturing or service strategy of continuous improvement by progressive elimination of all non-value-added activities through the creative involvement of every employee. Sounds good, very broad. World-class manufacturing strategy is employee involvement, total quality control or management, just in time, which is material handling and logistics, and simplification, which sounds nice, but not that easy to fully define. The tactics that they use in employee involvement are make the employee creative to solve problems, create improvement opportunities, and learn problem-solving techniques. The tactics for world-class manufacturing total quality control or total quality management, very good, right the first time, every time. That sounds reasonable. The use of variation control, which again kind of goes into Six Sigma. It's to satisfy your customer needs. Now, that's a good one for world-class manufacturing because it also concerns the external or the concept of external customers and internal customers. And then we look at just-in-time tactics. Compress all times, eliminate any activity that does not add value. Sounds reasonable. In production and in administration. So there's a lot more to it. We also go through in world-class manufacturing a long list of principles of manufacturing. And these can be drawn from many different areas. I'll go through a few of them. Know your customer and your competition. Reduce work in process. Reduce flow lines. Reduce distances. Reduce space. Reduce setup and changeover times. Produce and deliver at a smooth rate, or as close to that as you can get. Reduce the number of suppliers. That's an interesting concept, and we'll probably touch on that later on. Reduce the total number of parts. Of course, that's going to involve a lot of design. Make it easier to produce the product. Again, simplification. Provide the service without error. That's a nice thing to do. Change multiple path flows to express lanes. That's more manufacturing assembly lines. Efficient arrangement of workplace. Eliminate search, hold, idle time. We'll get into that shortly. Cross-train for mastery of more jobs than one. That gives you a lot of flexibility. Record and retain production, quality, and problem data at the workplace. And that's a more modern concept with employee involvement, and we'll see that a little bit later. Other things, assure that line personnel get first crack at problem solving. Look for simple, cheap, movable equipment. Reduce process variability again. Automate incrementally. Provide plural instead of singular workstations. And dedicate to continual and rapid improvement, which is one of the basic things. If we'll go through some of the others, but when we look at some of these things, they ask us to improve. They ask us to reduce space. They ask us to reduce time. But in most cases, no one ever tells us how we do that. How do we reduce time? How do we study something? And that's when we go back to the classical industrial engineering of motion and time study, which is lean manufacturing, basically. And when you look at motion and time study, there's two aspects. There's the motion study, and then there's the time study. And the motion study is probably the more important one, because the motion study is to take a look at what you're doing and try to improve it. Now, a very simple list of items, short list too, for improvement is when you look at a station or you look at an operation, the first things that should come into your mind is, can I eliminate? Can I combine? Can I change the sequence? And can I simplify? And really with those basic things, although there are long lists of improvements, those really sum it up. But again, we still need the skills in order to do that. And some of the skills are quite old. Taylor, I think, did his work about 1920, so that's about 100 years. And he listed the principles of motion economy. And those are very, very simple things. Tools should be closest to point of use. Materials should be closest to point of use. Repetitive work so that you know where everything is. It also looks at using two hands to work, not leaving anything idle. Simple fixtures rather than using your hand to hold something. So with these types of skills or guidelines, it makes it easier to come up with solutions. It also makes it easier to spot what's going on. And when you look at motion and time study, well, I kind of like to put them together, because the time study is actually coming up with the time it takes to do the job. Now, when you do a time study, your ultimate goal, I hope, is to set a standard. But what is a standard? Well, a standard, the time study standard, is the time it takes a qualified and well-trained operator to do a specific task at normal pace. Well, okay, let's take a look at that. Qualified and well-trained operator. Well, we don't want to take someone who just came in off the street and time them. They just haven't had a chance to get used to things and find out the best ways to do things. So that's quite logical. The time it takes a qualified and well-trained operator to do a specific task. Now, that's the hard one, because when we look at some operations, people don't do them the same each time. It's not repetitive. On an assembly line with a 40-second station or a minute station, though, it's a lot easier to do. But we're looking for a specific task. And the other thing that sometimes I think people make mistakes is that when you look at the specific task, now, is this the task that you're trying to improve? Are you going to set a standard on that, or is this the task that you should have? So it really means that if you're going to just look at how long it takes, you can take just the overall time and see how long it takes the job. And that suffices to tell you how good or poorly you're doing. But if you really want to do something with it, like set a standard, you want to already improve it before you take that standard. You want to make sure that you followed all the techniques and skills that are available, and make it a good station, a good operation before you set a standard. And then the other part of that is the time it takes a qualified and well-trained operator to do a specific task at normal pace. But what is normal pace? Well, normal pace, the definition is the speed of hand movements of dealing a deck of cards into two equal piles in half a minute, or walking at 3 miles an hour. And what people fail to recognize is that when they set this normal pace, if you look at the bell curve of human capabilities, this is way at the bottom. 95 or more, 97% of people who walking off the street should be able to work at that pace. Now, again, this pace means that you're working at this day in and day out. Of course, you're also given times for personal time, fatigue, and delays that are not your fault as far as the operator's fault. But when you go through that, you say, well, this is bare minimum. This is D work if you're in the classroom. But the variability, people can work, well, 65% of normal pace is really, anything lower than that is actually tiring. 140 or 150% of normal pace is possible, but not often. Usually in manufacturing, the highest you'll see is 140. But when you look at the difference between, let's say, 70% of normal pace and 140% of normal pace, that's a huge difference. And that's the speed of the operator. Well, if we set it at normal pace, well, then this is bare minimum. People, given some incentive, some desire to do work, should be able to do around 110 to 120%. Given more incentive, a better operator, better environment, you can see people producing at about 130%. Now, this is not just from a book. I've tried this over the years, and I found that it works. You can improve. I can step into a station, or I've done that before, where people were working at 70% and bring it up to 130% in a short period of time. Of course, that takes a lot of work as far as management goes, but it is possible. So when we look at motion and time study, we have the opportunities to improve the station with skills. We also have an opportunity to set a standard. Now, we have, that's a stopwatch time study standard, basically. But we do have predetermined time studies. Now, predetermined time studies like MOST and MTM and MODAPS and so on, they really are based on time study. The warehousing industry years ago set some warehousing standards for forklifts and operators and so on. And basically, they hired a consulting company. And what this consulting company did is they set standards using MTM1, which is quite detailed, takes a long time to apply, but they come up with some decent standards. And if you are in your own company and you do decide to do time studies and set standards, the goal of setting those standards is to develop standard data. And if you develop a system to utilize that standard data, you've got yourself a predetermined time standard system. So it all comes to play and all works out quite well. The advantages of stopwatch time study, and even predetermined time studies in that case, is the ability to break down, or the necessity to break down a job into its smallest feasible element. I mean, you're not going to say, pick up a screw as an element and pick up a gun as an element. You're going to be using the screw and the gun together. So you would want those in elements. And if you're going to do a stopwatch time study, you don't want elements that are too small that you can't time. When you put that together and you start looking at a station in its elements, you start to understand and you start to see things. You start to see, well, why is that person walking over there to get a part? And why are they reaching all the way up there and reaching into a bin that's all jumbled and trying to pick out a part and then bring it back and try to orient it in the proper orientation in order to put it together? And you start seeing these things. It doesn't mean you have to be a genius. It just means that you have to study and look at and break it down into its smallest elements. So motion and time study, although it's existed for years and years and years, and a lot of companies have forgotten about it, is still quite a valuable tool. It's also extremely valuable when you get into employee involvement. When you're trying to get employees involved in improving stations, continuous improvement, then you start to look at, how can I make these people aware? And if you start teaching the basics of methods improvement, motion study, and some time study, you train them how to look for those things. It is also an excellent tool in order to measure, to see, well, how do you know if you go from this one method to another method, whether it's better? Well, you have to be able to measure the time. Well, if you're only using stopwatch time study, then you've got to go and change this whole station, get the operator trained in it, and then time it, and then you find out, well, it's really not that good. Throw it out. Well, with predetermined time standards, you don't have to do that. You can look at the method of operation from the old method and then new method and do that without making any changes. So standards are used for planning and scheduling. They're used for measuring a person's performance, and they're also used for costing. So if you look at control, you look at planning, scheduling, and costing, that sounds like what a manager or a supervisor has to do. So I can't personally see how you could be a good supervisor, manager, vice president of manufacturing unless you had this information. And being a good supervisor with that information, it makes it easy. You know what people's capabilities are, you know what the standard should be, and you know what you're getting from the measure of that performance. So motion and time study is a very basic skill that I think you need in this day and age. We look at plant layout and material handling as another topic, the methods. And plant layout or facilities design, we look at material flow, we look at, and part of that is looking for the excess distances and too many steps that are involved, and then the type of material handling. When you get into manufacturing, we look at things like sequencing of operations and presentation of parts and using 3PLs. So the material handling and plant layout are all part of that motion and time study. Motion and time study really looks at a station, and plant layout material handling looks at the overall plant. We also look at production and inventory control, and in world-class manufacturing, they want to reduce work in process inventory, reduce finished goods. All of this can be done if we concentrate on a good plant layout and also the control. So production and inventory control do work hand in hand. Now, maintenance fits into that, because if you're going to adjust in time and you're getting really tight scheduling, for instance, having some of your major parts in-house only 4 hours before you really need them, you've got to be on the ball. And if you're scheduling or supplying a company that's doing that, you can't afford mistakes. Sometimes, companies, large companies, automobile manufacturers, at one time it was $3,000 a minute. I imagine now it's probably more, and they probably don't even want to think about how expensive it is when a line stops. But in order to do that, you really have to depend on your equipment. Now, that doesn't mean the equipment has to run continuously. It just means that it has to run when you want it to run or when you schedule it to run. So there's still plenty of time for preventive maintenance and preventive maintenance schedules and doing it properly, finding out what equipment is critical to you, the critical equipment, and applying the proper level of preventive maintenance from zero breakdown or zero preventive maintenance, which is breakdown maintenance, to 100% maintenance, which is replacing parts on a continuous basis and replacing equipment when you think it might get close to breaking down. And then, of course, one of the major things that we are thinking about is cost estimating, because we need to know what the costs are, not only cost estimating, but cost control. We need to know what those costs are, because that's the way we make our decisions. We look at one method, we look at another method, how much does this one cost? How much does that one cost? What's the return on investment, which is time value of money? And then we use that to make decisions. Now, it's not always the most important thing, but it certainly is a big factor. And without having motion and time study and plant layout and production control, you can't get your costs. You need to know what overhead is. You need to know specifically. You don't want an overall overhead cost. You want one that's like ABC, activity-based costing, where you can really say, well, this machine costs that much per hour, that machine costs that much per hour, this person costs this much, that person costs another amount, so that you can look at those and make those decisions. Those decisions are very important in using sequencing and 3PL because those are off-site, and the overhead costs are quite different between the two different facilities. Total quality management and ISO 9000. ISO 9000 hits on most of the things that you find in Kaizen engineering, in world-class manufacturing, in Six Sigma, and so on. So it's all a matter of total quality management. How do we look at what's going on? Now, I went over some of the things that we see here. And I think what I'd like to do right now is just let's take a look at what's going on and how that might affect us in manufacturing. So let's take a look. If you have a factory and you have an assembly line, which is I'm familiar with mostly, you've got a certain speed on your belt or your conveyor, and you've got operators, and space is quite costly, so they're probably about 3 feet apart. And now with social distancing, you're going to say, well, okay, let's split them up and let's put them 6 feet apart. Well, what you've basically done to your assembly line is you've cut the production in half. And that's quite serious. You've got half the production. Well, or you could go ahead and make your conveyor belt twice as long, but then you need more equipment, and you also need more space, which are 2 costly factors. So how can you get some of that 50% back? Well, let's take a look at the basic things that we were looking at. Let's look at motion and time study. Well, if we go through and we look at each station, and we see how can we make this station better. Now, again, this is taking a bad situation. Well, I don't know if you're saying social distancing is a bad situation, but we're taking social distancing, and how can we use that opportunity as an opportunity to improve? Because now we have to change everything. So everything's all jumbled up already. We might as well make it good. Now, when you look at the differences between station improvement, like bringing tools closer in parts, making them easier to grasp, parts presentation, sequencing operations. And I'm not sure if people are familiar with sequencing operations, but my first experience with sequencing operations was in the automotive industry, and it was years ago. And at that time, we had 11 different instrument panels or instrument clusters, actually. And if you looked at that, they came in on 4x4 foot pallets. Well, if you put those in a station, and again, for the automotive industry, you have a build that comes by and you have options. So you have a choice of 11 different ones. And if they come in on 4x4 foot pallets, well, that gives you 64 feet of station. And all that operator does is walk back and forth. Well, we got a little smarter and we looked at the scheduling, and we found out that some of the product we use 40% of the time, and some of the product we use 5% of the time. So we decided to put the pallets that we use the most closest to the middle of the station. Well, that helped a lot. That reduced it quite drastically. But then you come back and you do sequencing, and if you know ahead of time what you're going to be building, you have that list, and you can actually do the sequencing offline, depending on how much time you have before when you know what you need and when you have to use it. But you set that up, and in one box, 1 foot in length or width, you have those parts sequenced, and the operator just has to reach. Now the operator, instead of spending their entire time walking from one pallet to another, can actually just put their hand in the box and take it out. So if we look at some of those things, we can actually improve our efficiency. Now, recently I was at a plant, and the intent was to try to improve production. Well, when I looked at it, I saw that over the years they had gotten into some poor practices and didn't really notice it. But if you go ahead and you look at it, and the things jumped out to me immediately, because those are the kinds of things that I'm looking at and also teaching, and you see that tools aren't in the right place. People are searching for tools, they're searching for parts, there's a lot of walking in the station. All in all, when we cleaned that up, we got 25% more production without increasing the number of people. And all we added were a few bins, and tables, and a couple balance reels to hold tools, and maybe a few extra tools. And it really, the cost of that was insignificant compared to the increase in production of 25%. Well, guess what? If we did that, we've got 25% back from our 50% loss due to social distancing. Okay, now let's go ahead and as I mentioned when we talked about motion and time study. In motion and time study, when we looked at the ability of the operator, and if we set a standard at 100% normal pace, but we can get 130% of normal pace, or let's say, just make it easier, 125% of normal pace. Well, guess what? If we can get those people, and how you do that is by eliminating poor practices, but you also this is actually getting the person to work faster. Now, when you get involved with employee involvement, people are going to come up with those things. They're going to be motivated to do better. Hopefully, we're going to have some rewards, but they're going to be in a higher stature in the company where their opinion is going to be valued, and that makes has a tremendous effect on morale. So we can get that 125, even 130%. Well, if you go from 100% to 125, we're already there. We've got the 50% back. But there are other things that we can do. If we have an assembly line and we take a look at a line balance, which is taking the elements and trying to make each station the same amount of time based on our standards, which our standards should include personal fatigue and delay. They will vary somewhat depending on the operator, but the closer we get to that, the better, and the better the standard is, the easier it is to balance a line. Now, most lines, you're never going to get 95% balance. I don't think I've ever seen that, but you can get close to it. Most of the time, people don't even pay that much attention to it, and you're running at around 80 to 85% balance. And that creates problems too, because an operator stands there all day working on their station, and they look over to the person next to them, and they see they've got extra time in the station, and they're busy. The person is busy. They're busy all day. They're sweating. And the other person next to them, or down the line a little bit, they've got an easy time. It's not correct. It's not being fair. So when you try to balance that, you're correcting several things. You're improving the efficiency, and you're also making things fair. And that certainly helps employee involvement and employee morale. But you can get anywhere from, say, 85 to 90, you can get an extra 10% of efficiency just out of line balance. And then we go back and we start looking, well, how are the parts added? Okay, how do we bring them to the station? Sequencing, parts delivery, parts presentation, those can all have tremendous benefits in reducing the amount of time in the station. And there's another thing that we can use on assembly lines, and that is the use of sub-assemblies. Now, sub-assemblies, they reduce, so of course they have other benefits. You can test things offline. You don't have to wait till it comes to the line and find out that it doesn't work or so on. But by doing that, we reduce the complexity on the assembly line, and we allow the product or parts to be made offline. Now, of course, that involves a lot of redesign, but it's possible. Now, if you're trying to make up for that 50% cut in your production by having sub-assemblies, you can get a lot of that back. Now, you can do the sub-assemblies in a plant, just, the next room. They're still going to have problems with social distancing, but we could also go to the thing that I forget what it's called, but they did it in Japan. I'm not sure if they're still doing it. And that's where they contract out the sub-assemblies to the outside public. And people used to come to the plant, pick up their parts, the instructions, and sometimes even a small fixture, go home and on their living room table, kitchen table, put the parts together, bring them back to the plant, and get paid piecemeal. Now, piecemeal is a tremendous incentive. We don't like doing that right now, but under those circumstances, that would be great. We could also utilize social distancing and have those parts delivered by Amazon, UPS, and so on. So the person doesn't even have to leave their home. And you could actually take the part and send it to another subcontractor to test it and then send it to the plant. So we have all these tremendous opportunities that we can utilize that take into account WorldClass Manufacturing, Kaizen Engineering, Six Sigma, whatever you want to call it. And I'm going to quickly go through and list some of the things, the tactics that WorldClass Manufacturing uses. in his principles of manufacturing. Reduce distance, reduce space, reduce work in process, make it easier to produce the product, reduce reports, counting, inspection, audit, inventory, material handling, poor quality, reworks, rejects, delays, save space, increase capacity, reduce overhead costs, get employees involved. All of these things can come into play utilizing the skills of motion and time study, plant layout, production inventory control, measuring it with costing and time value of money. Maintenance management is always a good idea to protect your investments, but especially important in just in time. And then overall total quality, which I think it should be a given. Things should be made right the first time, every time. So these are some of the basics that we use. And I think certainly we can meet the challenges that are upon us right now. Now, I think I've gone about a half an hour or so. So are we ready for some questions?
Yes, we have a question already, and well, actually a few. I'll start with the first one. Just before, forgot to mention earlier that there are no slides. It's a no slide webinar today. It's more like talk. So if you haven't been able to see the slides, that's normal. We will have a transcript. Yeah. Sorry.
But I'm in an area where I don't have Wi-Fi, and luckily my phone works. So
yeah,
I have to work.
And that's actually, I think this works really well. I will send this transcript to those who request it. I already received some requests. And so first question, please go ahead and type any questions you have, everyone, about cycle time and take-it time. When the cycle time is greater than the take-it time, what's the time value of revenue loss of impact on business? I don't know if that might be a technical question, or not sure if it's clear.
Well, I need the definition. When you talk about cycle time, we're talking machine cycle time, we're talking about people cycle time. When the cycle time is larger than what you're scheduling, then you're going to have a problem. Obviously, you're not going to make the number of products that you need. You have to change something. You have to go to a second shift. You have to go to a third shift. Yeah. Any additional clarification on that?
Okay. Yeah. So I don't know if the person who asked the question can also clarify what kind of cycle time they are facing. Any other questions? So there is one question here regarding the, you mentioned earlier the small equipment, the use and the value in deploying small equipment as part of improvement. At the same time, we hear a lot about Industry 4.0, digital, and so on. So can you elaborate on that? What are your thoughts on the small incremental Kaizen style of improvements in the current situation versus maybe more radical technology driven, and what's the right balance?
Well, when you're looking at that smaller equipment and even getting away from total automation, you're giving yourself a lot more flexibility, and that seems to be what we need right now. We don't keep much inventory in, so when an order comes in, we don't have the part made. We want to access it, get the materials in, and produce just that number that is ordered. So we get away from larger equipment, which usually requires there's high speed, which is good, but also it's quite expensive. Setup time is expensive. Run time is expensive. We like to do long runs. We change over that much. So when we're using smaller equipment and let's say cell manufacturing as a possibility, we have a lot more flexibility in the run and setting it up, getting it going, checking it. Also, as far as quality control, it's important that we, when we make it, we start testing it and see if it works, see if it fits into, let's say we're putting it into another component. Whereas in larger equipment, you have a longer run. You might produce 100,000 and then test it and find out, well, we got to make some adjustments on the machinery. And what do you do with the parts that are no good? So I think the flexibility factor of small equipment and shorter runs is very important. But it also depends on your exact situation. So it's hard to say. You have to look at the exact situation and see what your possibilities are. And what you do is you compare the two, automated equipment versus small stations and fixtures and so on, and you can do.
Okay, thank you. So just a follow-up on the prior question. So it's the person was referring to people cycle time. So I don't know if that clarifies.
Well, when you're looking at people's cycle time, there's always the factor in there. Even when you do the you set the standard, and you can use normal pace or something a little bit above that, maybe 110% or so of normal pace, which is still quite easy to do. You always have a factor of the speed of the operator, and it's really hard to control that, and that can vary from day to day. A person comes in, they just don't feel good, or they had to go through traffic, or their kids didn't do their homework or whatever it is, and they're not in a good mood, and that can affect their whole day. So cycle time for people is difficult to set and also difficult to control. But if you know what the parameters are, the highs and the lows, and if you know that you have let's say a station that has got some difficult elements in it, you can, by line balancing it, you can make it even lighter. So that even if the person is not working at full speed, it's not slowing the rest of your line down. But a lot of that is going to depend on the supervisor. The supervisor has to watch every minute of what's going on and be able to judge the speed. And a good part about motion and time study, when you do motion and time study properly, you learn how to rate an operator. And that's a visual thing where you look at their speed and you judge how fast they're going. Now, it's not exact, it's not perfect, but it can be quite useful, put it that way. And it can be fairly accurate if you practice. So a lot of it will depend on the supervisor, and the supervisor may have to rearrange things, give the operator help, see what's going on. And of course, there are physical problems on a line with parts fitting together and tools working and speeds of tools and so on that can affect the time. So you have to check all the factors.
And someone said, how do you define or decide what normal pace is for a particular operation or task?
Well, that's a very, very good question. And the reason for that is that if you really want to do it right, you don't look at normal pace, because that's not really what you want to have. You look at a pace that you feel that you and your company and the people feel comfortable with. And you can set the standard at that normal pace. You can call that normal pace, or you can set standard time. Now, it comes from doing a survey of all the people and watching their speeds. It comes from management deciding what they expect from people. It comes from the type of industry and what the average pay scale is. But setting that normal pace, I mean, the old time standard is I said, the speed of movement, dealing the deck of cards into 4 equal piles in a half a minute, or walking at 3 miles an hour, and that's quite slow. So I wouldn't recommend that would be where you set and expect all your people to work, especially if you're given a good salary. I would say that the ideal thing would be to set your own normal pace or 100% of normal pace for your company, and everybody will agree that that's a decent pace. And of course, you have a range that you deal with. It'd be ideal if you could pay them more or reward them more for doing more than that pace or a significant bit, but it still gives you an idea of where the where a good or fair day's work lies.
So someone asked, correct me if I'm wrong, to recap. I think we can divide the task per operator, improve the process or improve the workplace in a way that helps the operator to do the task in time. And then it depends on the situation. Is that a good understanding?
Yeah.
Okay, great. So we have another question in supply chain, where we all have experienced disruption due to COVID-19. Do you foresee a reverse on the just-in-time and go back to keeping higher level of inventory to protect from other disruption?
Well, it's always, just-in-time, it has always been the prerogative of the company to how safe they want to be. What you have to look at is what the effects are of the stock out. I mean, you can have an inventory where no matter what happens, you'll have enough parts, but it's going to cost. And you have to decide what level you're willing to take. Now, if you're in an industry that if you're late one day, you're going to lose the customer forever, well, you better have the part. But if you're in an industry that recognizes that, stuff happens, and if every once in a while, if 3 or 4 days out of the year, you're late on parts for 1 or 2 days, then that's okay. That's acceptable. So you really have to look at the acceptability of it and how much it costs. And there are statistical approaches to stock out and how they'll cost and what inventory you need to prevent that stock out. So within the realm of production inventory control, those statistical methods are available, and you can utilize those, but you also have to keep track of what it's going to cost you. So if you want to be 100% never late, you better be able to charge enough for the product to cover those extra costs.
All right. Very good. Any other questions? I see a few that are mostly requests for the transcript. So we will definitely do that. Also, we are past the time. As you know, you can qualify for a professional development hour certificate. If you wish, an email will be sent with a link to a brief assessment. The assessment is expected to last less than 15 minutes. So with today's webinar, that will complete your professional development hour. And that's time to conclude and to thank you very much, Norman, for being with us, everyone as well. Very briefly, for those who are not familiar with CESA Systems Academy, we have showrooms, which actually have become more than showrooms, but mini think tanks, labs, where we host hundreds of executives per year. And today is, this is a webinar that's an extension of the of these CESA Systems Academy, but online. So we hope that you benefit from it. Please be in touch with us. You can contact me especially if you wish to receive any catalogs. We have a variety of catalogs, and I'll be happy to send them to you. Norman is on LinkedIn. You can see his profile here, and I'm also there. I hope to connect with you. If you wish to receive announcements for future webinar, if you're not on our LinkedIn group, please feel free to join. You could see it here, and you're probably, if you're online today, you probably are receiving my newsletter. So I look forward to seeing you in future webinars, and thank you again very much. Bye, everyone. Thank you again, Norman.
Thank you.
Thank you.